This is a video on graphing quadratics in general form without completing the square. The first question we need to answer is whether a given quadratic, negative x squared plus 12x minus 30, is concave up or down and has a maximum or a minimum. Looking at the leading coefficient a equals to -1, since it is negative, this is an indication that the quadratic is concave down and therefore it has to have a maximum. The maximum is at the vertex, so our next step is to locate the vertex. The max is at x equals the x-coordinate of the vertex, and the x-coordinate for the vertex in general form is -b over 2a, which is -12 over 2 times -1, which is -12 over -6, and that over -2, and that is equal to 6. And the y of the vertex is f of h, so I'm gonna plug in 6 into my equation to find the y. -6 squared plus 12 times 6 minus 30, and that comes out to be 6 also. So the vertex is at 6, 6, which also indicates that the maximum is at x equal to 6 and the maximum is equal to y equal to 6. Since we know that it is concave down and it has a maximum, the range is going to be from -infinity to the maximum, which is 6. And the axis of symmetry is always x equals to h, and h is equal to 6. The y-intercept is easily found if we go in the general form and we plug in x equal to 0. So it's going to be -0 squared plus 12 times 0 minus 30, and that is equal to -30. And with x equal to 0, the point is 0, -30. So let's try to see how all of these look. The vertex is at 6.6, 6, and then the y-intercept was at -30, and the axis of symmetry was the line x equal to 6. And using the axis of symmetry, we can find another point that is symmetric to the y-intercept and on the graph of the parabola if we pay attention to the fact that the y-intercept is 6 units away from the axis of symmetry and the symmetric point must be 6 units away on the other side. So this is a symmetric point to the y-intercept. It has a y equal to -30 and it has an x equal to 6 and 6, 12. And the only thing we have left is to find the x-intercepts. The x-intercepts can be found from the general form using the quadratic formula, -b plus or minus square root of b squared minus 4ac divided by 2a. So -b is -12 plus or minus the square root of the discriminant is 12 squared minus 4 times a times c. It comes out to be a 24, and the denominator 2a is 2 times -1, which is -2. So I have -12 plus or minus the square root of 24 divided by -2. And if I simplify this expression, this will be 6 plus or minus the square root of 6. Therefore, I have two x-intercepts, 6 minus the square root of 6, 0, and 6 plus the square root of 6, 0. I can now graph the parabola by connecting the points I found, starting at the vertex, go to the x-intercept and to the y-intercept, starting at the vertex, go to the other x-intercept and the symmetric point. And to wrap it up, let's also state that the domain is all real numbers, since our graph goes from negative infinity to infinity and there are no denominators in our equation, and the range again is from negative infinity to our maximum value, which was 6 for the y. Closed.